Hello. I thought I would do a little bit more challenging telescoping series. We did one in the quiz today, and I'll do that in a moment, or after this one. But here's the way the question might read. Find Sn for the following series. Find lim n goes to infinity Sn to determine whether series converges or diverges. Give full details. What this means is take this limit, show all the work, show what the series converges to if it converges, show why it diverges if it diverges. And in this problem here, I'm giving you a hint. Use partial fractions. Now, if you didn't see that hint and saw that, you'd say, boy, I hope this is a partial fraction. I hope this is a telescoping series. I'm going to use partial fractions to see if I can figure that out. And the way that you would know to do that is of a series of this type, 2 over k times k plus 2, something over k times k plus 1, something over k times k plus 3. Think that it might telescope. The other clue is this. Now, it's very difficult to find Sn if your series doesn't telescope or isn't a geometric series. So if I ask you to find Sn, that's a big hint that it's going to telescope or be geometric. This is clearly not a geometric series. So I set it up. This is the partial fraction decomposition. So then I say set this equal to this. I go through the math, cross multiply. People haven't had too much trouble with these, so I'm going to go through it kind of quick. I set up my two equations. I get a plus b is equal to 0. I get 2a is equal to a, so I get my two equations. A is clearly 1. B has to be negative 1. That means I can write my series this way. 1 over k minus 1 over k plus 2. Okay, so Sn, now Sn is just the first n terms of the series. And I'm just going to write out just a few terms. So when k is equal to 1, I get 1 over 1 minus 1/3. When k is equal to 2, I get 1/2 minus 1/4. When k is equal to 3, 1/3 minus 1/5. I'm going to write a couple more, or at least one more. When k is equal to 4, I get 1/4 minus 1/6. And I go on. What I'm going to do is I'm going to write down the last two terms. I'm going to write k is equal to n minus 1. I get 1 over n minus 1 minus 1 over n minus 1 plus 2. So it's going to be n plus 1. And then finally my last one. And I get 1 over n. Oops, that should be a plus. Minus 1 over n plus 2. So that's my Sn. Again, just to go over that, I just plugged in a bunch of terms. And I like to leave the last term and the term before so I can figure out what's going on. So I'm going to, this series telescopes, I got to look, no substitute, no cancellations yet, none yet. Finally we get this. So those cancel. I look for the 1/4. It cancels forward. Okay. So notice that things cancel forward. So we're going to get something here, which is going to cancel there. And we cancel forward, we're going to get something here, which is going to cancel here. So we cancel forward, which means that, again, this term is going to cancel with something, like this 1/4 was 2 terms ahead. This is going to cancel with something over here. This is going to cancel with something past Sn, so we don't worry about it. And this one's going to cancel right over here. Again, we cancel forward. So we're left with 1 plus 1/2. Everything else cancels, and we're left with minus 1 over n plus 1 minus 1 over n plus 2. So that's my Sn. Now, if you've looked at this series, you're probably guessing these terms don't matter and that my series is going to converge to 3/2. Well, what we know is that S, which is the limit of Sn, is equal to the limit of this. So I look at my limit. I want to see what the series converges to. So S is going to be the limit n goes to infinity of this partial sum, which is going to be 3/2 minus 1 over n plus 1 minus 1 over n plus 2. Clearly these limits go to 0, so I'm left with 3/2. So, therefore, oops, do I have enough room? Series converges to 3/2. Okay, just a quick review. The offset here is 2, so that suggests there's going to be 2 terms before cancellation occurs. The same, and you'll have 2 terms over here. I wrote out a bunch of terms. I figured out that what happens is that I cancel forward. So the plus term cancels with something 2 terms ahead. This 2 terms behind. So the 1/4 is going to cancel there. That means this is going to cancel 2 terms ahead. This will cancel 2 terms ahead. So all I'm left with is this. What this tells me is that if I add up a lot of terms, I'm not going to have much less left. It also tells me that the series, if it converges to the limit of this, which is just the same as the limit of that. That's just more parenthetical. So I figure, take my term for Sn, get my limit. And just for fun, if I had S's, let's say I want to find out what S100 is. Well, I would do this. I would plug in and I get 3/2 minus 1 over 101 minus 1 over 102. So really these 2 terms are pretty small. So already at 100, my series is pretty close. And if I wanted to find S1000, I do the same thing. I'd plug in 3/2. I get minus 1001, 1002. And what I'm trying to suggest here that is, as my index n gets bigger, then the series gets closer and closer to 3/2. That's why we say the series converges to 3/2, but because it means it's getting closer and closer. Okay, so that's a typical telescoping series kind of problem. So, hope that helps. Thank you.